All right, today we're cracking open one of the most powerful tools in your entire Algebra Chart Keepers course, Chart B. We're about to go on an adventure to find the secret rules of numbers, the hidden logic that makes all of math work so perfectly. So get ready because this is where you really start speaking the language of algebra. So let me just ask you, do numbers even have rules? I mean, you might think of rules as these boring things you just have to memorize for a test, but that's not what we're talking about here. Think of it more like a secret code, a hidden grammar that once you learn it, gives you the power to solve pretty much anything. And that's exactly what we're going to do in this explainer. We're going to explore that hidden grammar together. We're going to peel back the curtain and see the elegant, seriously powerful principles that have guided some of the greatest minds in all of history. Believe me, this is not just about passing a test, it's about understanding the deep structure of the world around you. So where do we even begin? Well, this secret grammar is built on something called properties. Yeah, that's the official name for these rules we're about to uncover. Just think of them as the absolute foundation of everything, and I mean everything we do in algebra. So what in the world is a property? It's actually pretty simple. It's just a statement that is true for any number. It doesn't matter if it's the number 2 or 2 million. These rules always work. They are the basic building blocks you're going to use to construct all of your solutions. Now, to really get a handle on these rules, we're going to travel back in time. Yeah, our journey starts thousands of years ago with this brilliant mathematician who basically laid the groundwork for fairness and balance in every single equation you will ever solve. Okay, picture this. It's 300 BCE. You're in Alexandria, Egypt. This city is the intellectual center of the ancient world. It's home to the Great Library, where scrolls and scholars from all over the world came together. And working right there was a man named Euclid, who we now call the father of geometry. Euclid came up with 3 core rules for equality, and what's so amazing is how simple but powerful they are. The reflexive property, that's like a mirror. A number always equals itself. Duh, right? The symmetric property means you can just flip an equation around, no big deal. And the transitive property, that's like a chain of logic. If A equals B and B equals C, then of course A has to equal C. It's all about order and consistency. And this quote just sums up that transitive property perfectly. It seems so obvious, doesn't it? But here's the thing. Euclid was the one who actually wrote it down, giving us this solid foundation that everything else is built on. But the story definitely did not stop in ancient Egypt. Oh no. The discovery of math's grammar was more like a global relay race, with the baton being passed from one genius to the next across centuries and continents. I mean, just look at this timeline. Over 1,000 years passed between Euclid and our next stop, and then another 800 years after that. These ideas took a really long time to develop, with each brilliant thinker building on the work of the people who came before them. Okay, our next destination is Baghdad, around 800 CE, right in the heart of the Islamic Golden Age. This was a city that was just buzzing with intellectual energy, and its center was the House of Wisdom. And here, a Persian mathematician named Al-Khwarizmi literally changed everything. He's the whole reason we call it algebra. It comes from his term, al-jabr. Al-Khwarizmi was a huge champion of the commutative property. This one tells us that for addition and multiplication, the order just doesn't matter. 5 plus 3 is the exact same as 3 plus 5. It's like a perfectly rehearsed dance where the partners can switch places and they don't miss a single beat. This property gives us so much flexibility when we're solving problems. All right, let's jump forward in time again. We're going to Renaissance France in the year 1623. Try to imagine a world filled with amazing art, incredible innovation, and discovery. And living in this exciting time was a young prodigy named Blaise Pascal. Pascal gave us the distributive property, and let me tell you, this is a tool you are going to use constantly. It lets us spread multiplication across the terms that are inside parentheses. And the analogy here is just perfect. You're taking that A on the outside, and you're scattering it like a farmer's seeds across both the B and the C. This is the absolute key to unlocking complex expressions. So our final historical stop brings us much closer to our own time, where we meet one of the most influential mathematicians of the 20th century, and she gave us the ultimate problem-solving tool. We are now in Göttingen, Germany, a university town that was known as the Mecca of mathematics. And it's here that Emmy Noether, a true trailblazer, completely redefined algebra. She shattered all expectations and gave us a profound new way to think about equations. Noether's huge contribution was her focus on the inverse property. Now, I want you to think of this as the undo button in math. For every number, there's an opposite that can take it back to 0 with addition, and a reciprocal that can take it back to 1 with multiplication. This is how we isolate variables. It's the elegant reset button that makes solving for x even possible. So, we've traveled all through history, from Euclid all the way to Noether. But why? Because these properties aren't just cool stories. They are the actual tools in your algebraic toolkit. Everything you do when you solve an equation is based on these powerful, ancient ideas. Let's put it all together right now with an example. See this equation? To solve it, first we use Pascal's distributive property to open up those parentheses. Then we use that inverse idea, the subtraction property, to undo the addition. And finally, we use the division property to undo the multiplication, and bam, we find our answer. Every single step we took is justified by one of these hidden rules. So, when you're working on your algebra, I really want you to remember this journey we just took. You're not just doing homework, you are participating in a conversation that's been going on for over 2,000 years. The next time you use the distributive property or you find an inverse to solve for x, remember Pascal, remember Noether, remember Al-Khwarizmi and Euclid. You are using the very tools that they discovered. You are, quite literally, walking in the footsteps of giants. And that kind of leaves us with one final thought. Math shows us that there's this incredible hidden logic just beneath the surface of numbers. So my question to you is, what other hidden logic governs our world? Start looking for the patterns, the rules, the grammar, and everything around you. You might be really surprised by what you find.